Good day everyone. On this occasion, I will tell you about the face of the earth. What is the face of the earth? Most of the earth's surface, about 70%, is covered with water. The remaining 30% is made up of the 7 continental land masses. Underneath the water that fills the ocean and the dirt and plants that cover the continents, the earth's surface layer is made of rock. This outer layer formed a hard, rocky crust as lava cooled about 4.5 billion years ago. This crust is broken into many large plates that move slowly relative to each other. The mountain ranges around the world form when two plates collided and their edges are forced up. Many other surface features are the result of the movement of these tectonic plates. The plates move anywhere from 25 to 100 mm per year. About 250 million years ago, most of the land was connected together. The rocky layer under the soil of the earth is called the crust. This comprises the continents and ocean basins. The crust has a variable thickness, being 35 to 70 km thick on the continents and 5 to 10 km thick in the ocean basins. The crust is composed mainly of aluminosilicates. The entire crust occupies just 1% of the Earth's volume. The temperature of the crust increases as you go deeper into the Earth. It starts out cool, but can get up to 400 degrees at the boundary between the crust and the mantle. The tectonic plates are actually floating on the molten asthenosphere, which is the lower mantle of the Earth. Earthquakes, volcanoes, mountains, and oceanic transformation occur along plate boundaries. The plates are in constant motion. The reason that tectonic plates are able to move is the Earth's lithosphere has a higher strength and lower density than the underlying asthenosphere. Their movement is dictated by heat dissipation from the Earth's mantle. Lateral density variations is the mantle result in convection, which is transferred into plate motion through some combination of frictional drag, downward suction at the subduction zones, and variations in topography and density of the crust that result in differences in gravitational force. How the shape of the Earth's surface? What shape is the Earth? It sounds like a pretty basic question, but it's trickier to answer than you might think. For starters, let's define what we mean by the Earth. You might not often consider this, but there is a whole bunch of atmospheres that is really part of our planet. The fact that the portion of our planet above us is gaseous and the stuff below us is solid is just a happenstance of our density. If we were made of volumes, we'd able be floating around and rarely bothering with the solid stuff way beneath us. Everyone agrees Jupiter is a massive planet, even though most of it is a gas, so don't be gas haters. That said, it is not easy to pick a satisfying edge of the atmosphere from which to define that the planet's shapes. We will go back to ignoring it. It's also not smart good at using the ground surface, because it changes every time there is a landslide, volcanic eruption, or Russian oligarchs' mining project. Instead, we will choose a more intuitive surface from which to explore the Earth's shapes, the sea level. This is a nice reference because water flows, so that its surface is flat. With respect to the direction of gravity, the liquid in your teacup cannot all bounce up at one side because gravity will put it back down until no point is any higher than another point. While this makes things look flat on a small scale, since the force of gravity on either side of your cup points is almost exactly the same direction. On a large scale, the surface is obviously curved. What is really going on here is that the Earth's attraction is producing an equidistant surface, a surface of equal gravitational potential. The fluid will flow in order to minimize its potential at all points. If it were to be pushed to higher potential, it will immediately flow back down again. The sea surface, therefore, defines an equipotential surface that we call the geoid, the notional shapes of the Earth. Why does the face of the earth change? First, erosion. Wind, water, and ice are the three agents of erosion, or the carrying away of rock, sediment, and soil. Erosion is distinguished from weathering, the physical or chemical breakdown of the minerals in rock. However, weathering and erosion can happen simultaneously. Erosion is a natural process, though it is often increased by humans' use of the land. Deforestation, overgrazing, construction, and road building often expose soil and sediments and lead to increased erosion. Excessive erosion leads to loss of soil, ecosystem damage, and a buildup of sediment in water sources. Building terraces and planting trees can help reduce erosion. Second, glaciers. In the Arctic and subarctic, glacial erosion has shaped much of this landscape. Glaciers primarily erode through plucking and abrasion. Plucking occurs as glacier flows over bedrock, softening and lifting blocks of rock that are brought into the ice. The intense pressure at the base of the glacier causes some of the ice to melt, forming a thin layer of subglacial water. This water flows into cracks in the bedrock. As the water freezes, the ice acts as a lever, loosening the rock by lifting it. The fractured rock is thus incorporated into glacier slope and is carried along as the glacier slowly moves. Abrasion happens when the glacier's ice and rock fragments act as sandpaper, crushing the rock into finely grained rock floor and smoothing the rock below. Meltwater streams of many glaciers are grayish in color due to high amounts of rock floor. Third, plate tectonics. The theory of plate tectonics describes the motion of Earth's lithosphere, our outermost layer of hard, solid rock over geologic time. Plate tectonics provides scientists with a great deal of information about the polar region's past. Earth's lithosphere is broken into 7 major and many minor tectonic plates. These plates move in relation to each other, slowly changing the location of Earth's continents and oceans. Geological evidence from Antarctica supports the theory that North America and Antarctica were connected approximately 1 billion years ago in the global supercontinent Rodinia. The continents eventually broke apart, merging again approximately 200. Fourth, volcanoes. A volcano is simply an area where magma or molten rock from the Earth's mantle reaches the Earth's surface, becoming lava. Most volcanoes occur at plates bordering, where the two plates are moving away or together. A few volcanoes, like the Hawaiian Islands, form from a hot spot or a weak spot in Earth's crust where magma forces its way to the surface. Volcanic eruptions may be explosive or effusive, depending on the lava chemistry. Silica is a mineral found in natural sands or quartz. High level of silica means very viscous lava, and low levels mean more fluid lava. Dissolved gas builds up in the volcano, much like a can of soda or other carbonated beverage. The higher the level of gas, the more pressure that builds and the more violent an explosion. The combination of silica and dissolved gas level determines the type of eruption and shape of the volcano. The last, earthquakes. Seismic activity is most often associated with tectonic plate boundaries. As plates slowly move, their jagged edges stick and suddenly slip, causing an earthquake. The gag reads underneath the Arctic Ocean, and earthquakes that accompany the volcanic activity found in the area. Antarctica, which lies in the center of a tectonic plate, does not experience many earthquakes. However, seismic activity is associated with eruptions of mountain erebus. Okay, thank you for your attention. See ya.